Good morning, everyone. I hope your Monday morning is off to an excellent start and that you are ready to get into geometry this week. First and foremost, I want to thank you for being so kind to our sub, Miss Rose. Miss Rose is the best. Her word is law. Um, Today and tomorrow, we are going to be doing note sheets. And then Wednesday, Thursday, and Friday, you'll have time to work on a performance and Mathia. I will have more info posted about that in your Canvas assignments. However, that being said, for today, let's go ahead and let's dive into some notes. This week, our topic is going to be all about different types of angle pairs. Our topic for today is complements and supplements. And our essential question is, how can I solve problems with pairs of angles? All right. So we are going to start by reviewing some definitions. The first definition we're going to talk about today is our adjacent angles. Now, you may remember this from last week, so yay for you if you do. If you don't, that's okay. That's why we're going to go over it. As a reminder, adjacent angles share a side and a vertex. We say that they are next to each other. So let's go over to our example box and let's draw an example. So let's say we've got our first angle. We'll call it A, B, C. And then our second angle, we'll call it DBC. We would say angle ABC and angle DBC are adjacent. They share their vertex B, and they both share the side BC. All right, excellent. Let's move on to our next term. We're actually going to skip supplementary angles for now, and we're going to move to complementary instead. Complementary angles are any two angles whose measure whose measures add to 90 degrees. They do not have to be adjacent. I'll give you a couple examples of complementary angles. First, we'll look at a pair of adjacent complementaries. So we've got our traditional right angle, which we mark with our little square. And if we give them measures, we could say this one's 60 degrees, and then this one would be 30. 60 plus 30 equals 90. So my two angles would be complementary. Another example, if I gave you an angle, let's say 35, then I gave you another angle of 55. Both of these angles would add up to 90 degrees. Last but not least, we have our supplementary angles. Supplementary angles are any two angles whose measures, you're probably sensing a pattern at this point, whose measures add to 180 degrees. Again, they do not have to be adjacent. So I will give you an example of adjacent angles first. If we remember, straight lines are 180-degree angles. So adjacent straight angles, or adjacent supplementary angles, sorry, make a straight line. We could say one of these has a measure of 100 degrees and the other one has a measure of 80. However, they don't have to be adjacent. You could have one angle of 45 degrees and one angle of 135 degrees. Any measures you like, as long as they add to 180. All right. Go ahead and take a second to write it down. I'll let you pause the video. I'll have you pause the video here. All right. And we're back to it. Let's look at some examples. So for our first set of examples today, we're not going to do anything with equations. We're going to keep it nice, easy, breezy. We are going to identify a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles in each figure below. So we'll start with our figure on the left, and we'll start with our complementary. I usually abbreviate that comp. Right away, we remember that complementary angles have to add to 90. So we see our angle CAD, that's over 90, so that's no good. That's not going to work. So which means really our only choices are angle BAC and angle RST. You want to check that in a calculator? Let's take a look. We said BAC has a measure of 37. RST has a measure of 53. 37 plus 53 is 90. All right. Let's go ahead and let's identify a pair of supplementary angles. Supplementary angles add to 180. And they would, if we put them together, they would make a nice straight line. So we look and we see, we're probably going to need one angle that's at least larger than 90 for this. So we look and we see, oh, CAD looks like a pretty natural choice, CAD. But now we need to choose our other one. What angle with CAD equals 180? Take a second and take a guess. All right, for your guess, I hope you said RST. Let's check it in a calculator just to be sure. CAD was 127. RST was 53. We add them together and we get 80, just at 180, just as we wanted. Last but not least, our adjacent. These angles are directly beside each other. Our adjacent angles, we really don't have many options. We see RST off to its own, so we can ignore that one, meaning our two angles are BAC and CAD. All right. I'm going to give you just a second to finish our next problem on your own, and then we will come back and share. All right, welcome back. Hopefully you got the answers I wrote on my piece here. If you didn't, take a second and check your math in the calculator, but we have to move on to our next session or our next piece. Your performance assignment is going to have you solving a lot of problems with supplementary, complementary, and adjacent angles. So I've decided to give you a 5-step process to help you. Step number 1, and our easiest step, is to identify your angle pair. You are looking for vocab. Look for vocab. You want to look for a sign that looks like this. You want to look for straight lines. Each one of those will clue you in on a different part of your problem. Once you get to that takes you to step 2. You are going to write an equation using your definition. Remember, adjacent angles are just next to each other. You're going to need some extra information, and we'll see that. Complementary angles, add to 90. Supplementary angles, add to 180. Step number 3, after you've written your equation, is to combine like terms. Easy step. We'll hopefully have had lots of practice with this by now. Step number 4 is to solve for your variable. And last but not least, step number 5 is to plug in and find a measure. Sometimes you may be able to skip step 5, depending on what your problem says. I wouldn't count on it, though. Go ahead and pause the video here so you can write down what you need to. And now we're going to work some examples on the back. We are going to start with the example labeled number 1 in the top left corner. In problem number 1, here's what we are given. We need to find the measure of angle DBC. Now, it gives us a diagram, but it doesn't really give us anything else. So the first thing we need to do is we need to decide what type of angles we have. I notice that we've got a nice straight line down the middle and that my angles are adjacent to each other. They're next to each other. Because they're a straight line, we know straight lines are 180 degrees. So we can say my angles are supplementary. And since they're supplementary, we can make a note that they add to 180 degrees. So let's use that information to write an equation. When we're writing an equation, I usually start with the left and I kind of work my way through the angles and pairs. Angle A, B, D plus angle D, B, C. I'm adding them together because they add to 180. That easy. Let's plug in our equations. We see A, B, D. The equation associated with it is 5x plus 47. So we'll plug that in there. 5x plus 47. You don't need to include the parentheses. Some people like to, but you don't need to. And then our equation for DBC. All right. We've got our equation. Some folks like to do different things here, but I like to combine our like terms. I see I have 2 x's. So I start by combining those. 5 plus 2 is going to be 7x. And then I also see I have 2 normal numbers, 47 and 63. So I'll combine those as well. 47 plus 63 is, feel free to use a calculator for this, 110. All right. Now this looks just like those equations we solved the second week of the quarter, right? Easy. We subtract 110 from both sides, trying to cancel it out. We're left with 7x equals 70. We divide both sides by 7. And it leads us to x equals 10. Now, here's the problem. Our problem doesn't want the value of x. We want the measure of DBC. So we have to look at our graph and we have to figure our diagram and figure out what's our equation for DBC. It looks like DBC is equal to, if I trace it, DBC, 2x plus 63. Now that I know x is 10, I can take that x and I can replace it with a 10. So it'll be 2 times 10 plus 63. Plug that into a calculator and you'll get the measure of DBC is 83 degrees. Okay, one problem down. That wasn't too bad, was it? Let's look at our next problem, problem number 25. Here's what we are told. ABC, the whole thing there, is 95 degrees. Our job is to find the measure of ABD and the measure of DBC. Now, first thing we need to do is we need to discover what type of angles they are. It's clear that they're adjacent. They're right next to each other, but it doesn't look like we have the little box for a 90-degree angle, and they definitely don't form a straight line. Because of this, we are just going to assume that they are adjacent. When they're adjacent, they don't have something special that they add to. We have to read it in our problem. So let's start putting it together. Angle ABD plus angle DBC equals the whole thing, ABC. Now, if you've been paying attention to our problem, you're like, Mr. O, they already tell us ABC. The whole thing is 95. So we can go ahead and fill that in there. Let's plug in our equations. ABD is 2x plus 23. DBC is 9x minus 5. Just like before, we can combine our like terms. 2x and 9x combine to 11x. 23 minus 5. We do 23 minus 5, we get 18. So not 11x plus 18 equals 95. If you don't like combining them like that, I would just combine the x's and then get rid of these one at a time. Okay, that works just fine too. I know some of you like to do that. So now we're looking and we think, okay, how do I get rid of a plus 18? What's the opposite of adding 18? That would be subtracting it. So we subtract 18 from both sides. We'll get 11x equals 77. And then we're going to divide both sides by 11. We'll get x equals 7. All right. Now this one's even meaner than my last one because it asks for the measure of both angles. We can't just find one, we have to find both. Annoying. All right. So let's start with ABD. ABD is 2x plus 23. Remember, we can find that just by tracing it. We can rewrite this as 2 times 7 plus 23. 2 times 7 is 14 plus 23 is 37 degrees. All right, now we do the same thing with DBC. DBC is 9x minus 5. We plug in, it'll be 9 times 7 minus 5. 9 times 7 is 63. Minus 5 is 58. So our two answers are 37 degrees and 58 degrees. If you're looking for an easy way to check your work, you can always add your answers together and see if you get 95 or whatever the problem is added to. We're going to work one more, and the rest are going to be yours to work for today. Feel free to use each other as help when we're working on our own. Feel free to ask Miss Rose or play back the video as many times as you need to, all to bump up my YouTube views. They're bad. All right, let's look at our last one, number 3. For our final problem, we are going to find the measure of angle DBC. We know that these angles are adjacent. They're right next to each other. DBC, all right there, cool. I look and I see right away our little square. What type of angle does this mean they are? Pause and talk to a neighbor. Anyone who said complementary is correct. And what we know about complementary angles is that they have a special property. They add to 90. So let's set up that equation. ABD plus angle DBC equals 90. We know this because they are complementary. So let's plug in. ABD is 9x minus 31. DBC is 2x plus 22 equal 90. Just like before, you combine your like terms, 9x and 2x. 9 plus 2 is 11. Now be careful. This next one can trip people up. One of the biggest mistakes I see here is when we have a negative and a positive. When I'm combining these, I read this as negative 31 plus 22. I do that. I put it in a calculator and I get, negative 9. Since my answer is a negative, I will put minus 9 equals 90. All right, next step, we have a minus 9, so let's get rid of it. Let's add 9 to both sides. We'll get 11x equals 99. Divide by 11. We will get x equals 9. Now, I want you to take a second and talk to a neighbor. Which equation am I going to plug into? Am I going to plug into the equation with 9x minus 31? Or am I going to plug into the equation 2x plus 22? Chat with your neighbor. Okay, if you and your neighbor said, we're going to plug into the 2x plus 22, you are absolutely correct. We get this because if we look at our problem, it asks for DBC. DBC is our equation 2x plus 22. We'll do DBC equals 2x plus 22. We know x is 9, so we'll say 2 times 9 plus 22, which is equal to 2 times 9 is 18, plus 22 is 40. Okay, so that concludes our first lesson on working with complements and supplements. Your job for the rest of class today is to solve problems 26, problem 10, and problem 11. A couple notes. Problem number 10 does not give you a diagram, but if you're reading the problem, it tells you what vocab to look for. So be careful. Also, problem number 11, you only have to solve for x. You don't have to plug it back in. I'm not going to make you do that. All right. On that note, I hope you all have a wonderful rest of your day, and I will speak to you kind of sort of tomorrow. Once you are done with your sheets, please take a picture and submit the pictures on Canvas or store them in your binder so that you can have them when I return. Great job and have a good day.